In this video, we access a Windows file share securely over the internet without a VPN. Hello everyone, I'm Travis and welcome to my channel. In this video, we review SMB Over QUIC, a secure encrypted way to access Windows file shares over the internet without a VPN. Before that, please like, subscribe, and share with a friend. That helps others find this channel and is greatly appreciated. Check out my courses on hybrid identities with Windows AD and Entra ID, Azure Virtual Desktop, Windows 365 with Intune Management, and my newest course, A Beginner's Guide to the AZ900, available at udemy.com. The links are below. And thank you, channel members. Your support is appreciated. Back to it. What is SMB Over QUIC and why should you care? I've been in IT for over 25 years, and I know a lot of companies would like to remove their dependency on Windows file shares, moving that data into SharePoint, for example. But many companies lack the resources and time to actually do that, and sometimes there just isn't a better option to store data. That leaves us with Windows File or SMB shares, an ever-growing repository of files that become less useful as they age, but no one seems to want to get rid of. What I'm trying to say is that for most of us, file shares are going to be around for some time. And as services move to the cloud, such as Exchange and other Microsoft 365 products, as well as SaaS-based third-party apps, the need for users to connect to the private network with a traditional VPN decreases. But if you're hosting SMB file shares, you're certainly not going to open SMB port 445 to the internet. That's where SMB Over QUIC comes in. It provides a way for users outside a private network to access SMB shares over a secure connection authenticated with Kerberos without using a VPN. Let's dig into how it works. QUIC is an IETF standardized transport layer network protocol. It's not new. It was initially designed by Google back in 2012. It improves performance by multiplexing UDP connections, and all connections are encrypted with TLS 1.3. It acts sort of like an SMB VPN for remote users. All SMB traffic, including authentication, goes through a TLS 1.3 encrypted connection. All SMB traffic flows through that connection, so SMB features work the same as they would without QUIC. Also, we can use both SMB and SMB Over QUIC on the same server, so clients have the same experience inside and outside the network. Here's what we need to get started. The server has to be Server 2022 Datacenter Azure Edition, or any edition of Server 2025. The server needs a trusted certificate. This could be from your own PKI or a third party like Network Solutions or Let's Encrypt. Windows 11 is the only supported client. The SMB server and client should be joined to the same domain. A domain join configuration is recommended. However, it will work in a workgroup configuration if the client has an account on the SMB server. The server needs line of sight to a domain controller. Also, the server needs inbound UDP port 443 open to the internet. Do not open port 445 to the internet. If you do, you can expect some visitors, and not the good kind. Next, let's review some configuration options. We can configure SMB Over QUIC from the Windows Admin Center on Server 2022 Datacenter Azure Edition. Microsoft's documentation states that configuring SMB Over QUIC with the Windows Admin Center on Server 2025 is not supported. There's a PowerShell option we can use instead. We'll review both in the demo. By the way, configuring SMB Over QUIC on Server 2025 with the Windows Admin Center may work by the time you watch this. Check for updates in the Microsoft docs. The link is below. If you install Windows Admin Center on the SMB server, it has to use a non-standard port. It uses TCP port 443 by default. We need that for the KDC Proxy. We'll talk about that shortly. Also, if you have a PKI, you can use that to create the server certificate. SMB Over QUIC requires a trusted certificate. There are benefits to using a PKI if you have one. On the screen are the requirements for the certificate. I don't have a PKI in my lab, so we'll use a third-party certificate in the demo coming up. It's easy to get a free cert from Let's Encrypt to use for testing. Let's move on to the KDC Proxy. It's not technically required for SMB Over QUIC, but strongly recommended. We wouldn't put a domain controller on the internet, but sometimes we need to authenticate clients not connected to the private internal network. That's what a KDC Proxy is for. It relays requests coming from a public network to a domain controller. Without the KDC Proxy and SMB Over QUIC, clients would default to the NTLM v2 authentication protocol. Even with NTLM authentication, the traffic is still secured in the TLS 1.3 tunnel, but Kerberos is more secure, and we don't want to create additional dependencies on NTLM authentication. The KDC Proxy is used for the RDP gateway and direct access service, as well as SMB Over QUIC. It's enabled from the Windows Admin Center or PowerShell. The KDC Proxy requires inbound TCP port 443. Be sure to open that up on the local firewall and any networking devices between the SMB server and the internet. We also have to configure the client to use the KDC Proxy. That can be configured with a group policy or Intune. We'll jump into the demo in a minute. The lab has 2 domain joined servers, both running in Azure. One running Server 2022 Datacenter Azure Edition with the Windows Admin Center. The other is Server 2025 Datacenter. My lab doesn't support an offline domain join client. The demo will use a Windows 11 24H2 client that isn't domain joined. The configuration works, but we'll get a login prompt when accessing the shares. An earlier version of Windows 11 will work, but 2024H2 shows SMB Over QUIC specific events in the event log. We'll start by installing a Let's Encrypt certificate on the server. Then we'll configure SMB Over QUIC and the KDC Proxy with the Windows Admin Center and PowerShell. After that, we'll apply client settings and then test by accessing the SMB share over the internet with domain credentials. Let's get started. Here we are logged into the server. Let's start by getting the public server certificate. This example will use a certificate from Let's Encrypt. You can use whatever certificate provider you prefer or even an internal PKI, as long as that certificate meets the requirements and is trusted. First, make sure you have a public DNS entry pointed at the server's public IP address. It won't work to point the client at a server's public IP address. Let's verify the public DNS settings by running nslookup, specifying the server name and the public Google DNS server. That looks good. It's returning a public IP address for that server name. If you're using split DNS, make sure you have an entry for your internal and external DNS servers. If the domains are different, you may need to add a CNAME to DNS. The Let's Encrypt documents recommends using the Surbot Acme client for Windows. Unfortunately, Surbot discontinued support for Windows. For this example, we'll use a client from Certify the Web instead. It was easy to use and free for evaluation. Let's download the client. Once downloaded, we'll run the installer. Default settings are fine. And we'll finish. Once the installation is finished, we'll go into the client. It gives us a message that the license isn't activated. Let's click New Certificate. We have to add some registration information before we can add a new certificate. Start by giving the certificate a name. SMB Server 2025 certificate for this example. Add the domain name. This example will use the fully qualified domain name smbserver2025.seraltos.com. And add. Go to Advanced. We'll select the certificate authority Let's Encrypt. Next, we'll go to Signing and Security. Set the public key algorithm to ECDSA P256. We can leave the rest and go to Authorization. We have the option to authorize from a website on the local computer. That requires installing IIS and allowing port 80N. This server doesn't have the web service installed, so let's select Challenge Type DNS. We'll change the DNS update method to manually. We get a warning that this is only for testing and we have to manually update the DNS settings for renewals. That's fine for this demo, but that would probably be problematic in production. As indicated earlier, if you're running this in production, a PKI is probably the best bet, or pay for a certificate. This example is just for testing. Let's click OK and request the certificate. That provides us with a text record, name, and value. These need to be added to DNS. That's used to validate ownership of the domain name. The video will pause here while the text records are added to DNS and given some time to propagate. We'll resume once that's finished. The text records were added and some time has passed. Next, let's request the certificate again. And that was successful. Now that that's done, let's go into certificates on the local machine. We'll manage computer certificates and go to Personal, Certificates, and there's our new certificate. Next, let's open the certificate and verify everything's correct. We'll go to Details. If we look at the signature algorithm and the signature hash algorithm, it's set to SHA-384. That's higher than the SHA-256 required for SMB over QUIC. If we go down to subject, that's the name of the server. Public key and public key parameters look good. Under enhanced key usage, server authentication is set to 1.3.6.1.5.5.7.3.1. That's also required. And if we go to key usage, it's set to digital signature. And finally, subject alternative name. That shows the name of the server. All those settings look correct. We can now move on to configuring SMB over QUIC. We'll do that through the Windows Admin Center next. The computer used for this example is running Server 2022 Datacenter Azure Edition. Only servers running Server 2022 Datacenter Azure Edition or 2025 support SMB over QUIC. One important thing to note, we can run the Windows Admin Center on the same computer we're enabling SMB over QUIC on, but don't use the default port. For this example, the Windows Admin Center is using port 6700. SMB over QUIC uses UDP port 443, and the KDC Proxy uses TCP port 443. No other web application can use the same protocol or port. We can view what's listening on 443 by opening the command prompt, and we'll type in netstat-ano, and then we'll use find to find 443. This shows there's nothing listening on port 443. Only outbound connections are established. We'll close that. Next, from the Windows Admin Center, go to Settings. Under File Share SMB Server, go to File Sharing Across the Internet with SMB over QUIC, and click Configure. Select the public certificate we added earlier. I'm using a different server for this example, but the certificate was created the same way as we saw before. Once the certificate is selected, we get the fully qualified domain name clients will connect to. Select that. And of course, if you had wildcards or other host names, you would select those also. Make sure the KDC Proxy is enabled and leave it to the default port. We can view advanced settings. We'll leave those set to the recommended value and enable. The first time I ran this, I got a message that it couldn't connect to the SMB server over QUIC. To fix that issue, open the local group policy editor and go to Computer Configuration, Administrative Templates, System, Credential Delegation, Allow Delegating Fresh Credentials. It was enabled, so let's go to Show, and the value shows the SMB server but not the fully qualified domain name. Update the value to the fully qualified domain name, and apply. That resolved the issue in my lab. Back to it, we get a prompt for the administrator's credentials for PowerShell double hop. Let's provide an admin account, and continue. And there it is. It shows that SMB over QUIC and the KDC Proxy is enabled. That's how to configure SMB over QUIC with the Windows Admin Center. Next, we'll do the same on another computer, this time with PowerShell. This is a Server 2025 Datacenter VM, joined to the domain, has a public certificate, and UDP port 443 is open. Before we get started, let's view the thumbprint for the certificate. Let's go to Certificates for the local computer. Manage Computer Certificates. We'll minimize PowerShell. And from Local Computer Personal, Certificates. We'll open our certificate, Details, and let's find Thumbprint. It starts with 26 and ends with B7. We'll need this coming up. We'll leave it open and let's go back to PowerShell. Let's zoom in. Be sure to open PowerShell with elevated privileges. We're going to make some system changes coming up. These commands come from the Microsoft Docs. A link is below. The first command will get our certificates. We have two showing. The one we want starts with 26 and ends with B7. We're going to copy the subject, and we'll paste that into the next command, replacing subject name. Now we can run this command. That creates a variable for the certificate. We can see that variable by typing in $server cert. There it is. Next, we just need to enable the SMB certificate mapping. We'll update the server FQDN. Next, we'll run this command. It shows the certificate mapping on the screen. If we go get SMB server certificate mapping, and we'll format that as a list. There it is. And we can see the type is QUIC. Let's move on to enable the KDC Proxy. Microsoft has a note in the documentation that this configuration will be part of configuring SMB over QUIC in the future. Check the documentation to make sure that this step is needed. Again, the links are below. We'll start with the command that adds the URL reservation and sets the registry keys for the proxy. Nothing needs to be updated here. We'll just select and run all. F8 or run selection. We'll scroll down. We need to copy the thumbprint from the certificate and add it for one of the next two commands. It's showing on the screen. We can also go back to Certificate Manager, and we add that thumbprint right here. We'll copy that and go back to PowerShell and paste that in. Once that's updated, we'll run these two commands. Let's go to the next command that starts with netdom. Use this if there are multiple names for the server. The netdom command adds the additional SMB over QUIC server names to the SPN. The first computer name is the alternate FQDN, and the last name after add is the fully qualified domain name of the server. Update and run those commands if needed. For this example, there is no other name, so we'll just skip it. The next two commands set the KDC Proxy service to start automatically and then starts it. That is how to configure SMB over QUIC with PowerShell. Don't forget to allow inbound port 443 for both TCP and UDP. Set that on the firewall and on any network security group in place. TCP port 443 is used for the KDC proxy, and UDP port 443 is used for SMB over QUIC. Let's move to the Windows 11 client for testing. Before we can test, we need to apply settings to the client that specify the KDC proxy server. In production, we would apply this setting with a group policy or Intune configuration. For this example, though, we're applying the setting to the local computer policy. Let's open the local group policy editor. And we'll go to Computer Configuration, Administrative Templates, System, Kerberos, and open Specify KDC Proxy Servers for Kerberos clients. Let's enable the setting. There are instructions and a couple examples on the screen to create the client mapping. Let's open up Show. The value name has to be your internal Active Directory domain suffix. This example is seraltos.com. And then we add the KDC proxy server in the format on the screen. Let's click OK and apply. We'll close that. Next, let's restart the client so those changes take effect. The video will pause here and come back once it's restarted. It's time to test. Unfortunately, my lab setup doesn't have a way for me to test with an offline domain joined computer, like a laptop user would. But we will connect to the share with domain credentials. Let's first try to ping one of the SMB over QUIC servers. It won't respond to a ping, but it does show the public IP address. Now let's go to File Explorer and open a share on that computer. After a couple seconds, we get a login prompt. We'll enter the domain credentials. There it is. Now we can access that share. Let's create a file. And if we go back to the server, we'll go to File and Storage Service, Shares, and if we open that share, there's the file we created. Let's go back to the client. This time we'll connect to the other server, but we'll force QUIC. Let's open a command prompt. We'll use the net use command, mapping the share to the Y drive, but forcing the transport QUIC. This is the server we configured with the Windows Admin Center. We'll enter the domain credentials. We can see our active connections with NetUse. And if we go back to File Explorer, we have a Y drive. If we go back to the command prompt, let's run netstat-na, and we'll find connections with 443. That shows the two UDP port 443 connections going to the file servers. Next, let's open Event Viewer. Let's go to Applications and Services, Microsoft, Windows, SMB Client. And we'll go to the connectivity log. If we look at event 30832, that shows that the connection was successful using the transport QUIC. This event is only available in Windows 11 24H2 and newer. That is how we can securely connect to a file share without a VPN using SMB over QUIC. I hope this video helps you better understand how to configure SMB over QUIC. Please don't forget to like and subscribe, and thanks for watching.